Finding the X and Y intercepts of quadratics and being able to solve quadratics is the next component that we want to look at. And we're going to start with finding the X-intercept in this equation. So when we want to find the X-intercept, we're going to let the when we want to find the Y-intercept, we want to let X be 0. And when we let X be 0, we will substitute 0 wherever the X is. So we have 0 squared minus 0 minus 12, and so Y equals negative 12. So it's pretty easy to find the X-intercept. And of course, if you have your graphing calculator, using your graphing calculator, you can graph that quadratic and easily find where the intersection occurs. And I encourage you to use your graphing calculator if you have one. But if you don't have one, of course, you have to work this out by hand in order to find the intercept there. Now, finding the X-intercepts is a little more involved. If you're finding the X-intercepts, you are actually solving the quadratics. So that's going to be basically one and the same when you're finding the X-intercepts. And if you think back to some past algebra classes, in order to find those X-intercepts, you have many techniques to do this, but one of the three main ones is to use factoring, to use the quadratic formula, and of course you can use graphing. You can use completing the square. And there are some other techniques that you can use as well, but basically we're going to look at the two basic factor and quadratic in terms of what I'm going to show you today. I'll leave graphing up to you, to those of you who have a graphing calculator, on how to do that. So if we go back up to our example problem here, y equals x squared minus x minus 12, and we are looking for the x-intercepts, which also means that we're wanting to solve that equation, and we're using the factoring technique. We would think of the 12 over here to the side and think of factors of 12. And it's easiest if you just go down the list: 1 and 12, 2 and 6, 3 and 4. And if you go in numerical order, 1, 2, 3, 4 is already on your list. And if you've gone in numerical order and you get to a number that's already on your list, you know you have them all. If you just jump around helter-skelter, you can get them all, but then you don't know if you have them all. But if you make a routine of it, of going always in numerical order, and then when you repeat, you know that you have all the factors possible. The next thing you have to think about is the sign of that last term. Because that last term is negative, we have to subtract the two factors. And so when we subtract 12 minus 1, we get 11. 6 minus 2, we get 4. And 4 minus 3, we get 1. And so we look at that number after we picked out the factors to see which of those match the middle term. And so the 1 is the one that matches the middle term. We don't really concern ourselves about the sign at this moment, just the fact that it was a 1. Now, because we know which two factors to use, now we're ready to set up our factors. So we know we have x and x, and we know we have 3 and 4. Because we subtracted, that tells us that one of the factors was positive and one of the factors were negative. Because this middle term is negative, that tells us the bigger of those two numbers has to be the negative number. And so that makes the other number positive. And so that is what the clues are to help us know how to factor. And so as we're factoring, the other things to remember is to keep in mind that now this equation is in factored form. We haven't solved it yet. We only have it in factored form. To actually solve it, we now have to take each of those factors and set them equal to 0 and solve each of those little equations, and so we get x equals -3 or x equals 4, and that gives us our solutions. So we have factored form versus solutions, and it does make a difference. And then if we had a solution set, that would be when we wrote those two answers, -3 and 4, in a set for the solution. So again, it's all about terminology and how you write your answer and how you express that answer and what it means. So a question you might encounter will depend on how the question is worded, on which of those methods you might give that particular answer. Is it asking for it in factored form? Is it asking for it as a solution, x equals something? Or is it asking for the solution set? Do you write it as a set? So that's all important in terms of how you interpret that answer. Now let's look at another sample problem. Y equals x squared plus 5x plus 6. And anytime we can factor, that's usually the quickest method to solve a quadratic. As you practice factoring, it tends to get easier. For you folks, it's probably going to be a refresher course in how to do it. But again, we look at that last term, factors of 6. In this case, it's 1 and 6 and 2 and 3, and we have all the factors. With the last term being positive, this time we're going to add the two factors together. So 1 and 6 would be 7, and 2 and 3 would be 5. So the two factors that match the middle are the 2 and the 3. So that makes our factors x and 2 and 3. Because the middle term is positive, that tells us both of these factors are positive. If the middle term had been negative, that would have told us both of those would have been negative in terms of adding them together. So again, those are the factors that make the solution. The solutions would be x plus 2 equals 0, x plus 3 equals 0, so x equals -2, or x equals -3 for the solution. So please keep that in mind in terms of how you would factor to find solutions. Now, it is possible that when you graph quadratics, that the graph does not cross the x-axis. And when it does not cross the x-axis, there are no real solutions possible. And so in that case, when it does not cross the x-axis, that is when you got into imaginary numbers. No, we're not going to deal with imaginary numbers. We would just say there are no real answers for our solutions. But because of that, we also got into the technique of using the quadratic formula to help us solve problems. And so what is the quadratic formula? The quadratic formula is a method that when factoring is not easy to do, we sometimes went to the quadratic formula. So even though you can factor, the quadratic formula is a method that you can use to solve quadratics that will work every time. So the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. And again, the a, the b, the c are all the coefficient values in your quadratic equation. So if we had an example problem, y equals x squared plus 3x plus 1, we would use the coefficients to plug into that problem. So x is going to equal the opposite of b, so negative 3 plus or minus the square root of 3 squared minus 4 times the a value, which is 1, times the c value, which is 1, all over 2 times the a value, which is 1. Now, I recommend that you simplify under the radical first. So 4 times 1 is 4 times 1 is 4. And 3 squared is 9. So 9 minus 4 is going to be 5. So we get negative 3 plus or minus the square root of 5 over 2. Now this does not come out to be a perfect square, so we end up having to find the decimal value for the square root of 5. And so remember that because of this plus or minus, we get 2 answers. So we have to do negative 3 plus the square root of 5 over 2, and we have to do negative 3 minus the square root of 5 over 2 and find each of those answers. Each is a solution. So this turns out to be negative 0.38, and this turns out to be negative 2.62 when you calculate that on a calculator. And usually that is the case when you use quadratic formula, that it turns out to be a decimal, and you usually have to end up rounding because the radical is not a perfect square. And it is cases that it does turn out to be a perfect square because you use the quadratic formula, and that's okay too. But oftentimes it is not a perfect square, and it is going to be a decimal value that you have to round. But be careful about your rounding. Be sure you follow the correct rounding rules for that. Okay, I want to end up with doing some application problems for quadratics that you have in your notes. So that's the last thing that I want to go over.